Oh, yo, what's up, everybody? Welcome back. Today, we are working on implementing OpenGL for our virtual GPU. So, context for this is that we've been experimenting with the idea of what would we have to do to make our own graphics card, right? So, I imagine it would be fun at some point in my life to, get like an FPGA, program this thing with like GPU and do something with it, right? But the problem is that I have no idea what a GPU is supposed to do. So we've been kind of trying to like walk the software stack from top to bottom in the hopes that if we implement a fake graphics card, completely virtual, maybe at that point we will then understand what needs to be done for a real GPU. And we can do it this way. We can iterate much faster because writing software is easier than writing hardware. And then once we understand what like the interface between software and hardware is supposed to be, then we can implement it. So we have kind of like tackled this from a few angles. We've got this like QEMU virtual machine. This is like an open source virtual machine. And in this, we've injected our own PCI card. This thing like renders to the QEMU window and we can like put stuff in it, whatever. And we've kind of like done like a couple experiments here. One was that we did like the Linux kernel has like a DRM interface, which is not digital rights management, but this is direct rendering manager or something like that. This we have hooked up to like a GPU driver that we wrote. So we wrote like Sphero GPU or something. And we've kind of like implemented this interface for this, right? Which means that this guy talks to this PCI card and an application app can talk to this DRM subsystem and he can like draw stuff on the screen. So we've done like that experiment. We've drawn like a little smiley face on the screen, animated him by using like what is essentially software rendering. This gives us like a pixel by pixel interface for us to use, but it also allows us to extend the default set of parameters that you can like run on this like DRM interface. You can extend this, and so we've extended this with like a fixed function pipeline. So we have like upload verts and like texture and like transform. Those are legible letters. You guys can see what this is. Let's just remember what I wrote, and we'll kind of use the words to make it sound like we did something, but we can just remember, right? And so we have this little demo app. Let's see if we can start it up somewhere. So if I type run, this launches like a virtual machine. And if I go in here and I run test app dev dri card 1, this no longer does any like display to the screen, but we can just imagine. We can imagine that we had implemented that. And what we are working on now is trying to implement OpenGL for this thing. So the reason that this says what it says now is, hey, create a calling Sphero GPU create screen, is because we were trying to implement these like, we're trying to integrate with this library called Mesa. Mesa is kind of like this OpenGL / Vulkan implementation for a bunch of graphics cards, all open source. And what we're kind of hoping is that like he can talk to this DRM device and he can leverage these commands that we've created in order to do some drawing. Now, obviously these commands are going to need some work once we find out what Mesa expects, but the idea here is the same, that Mesa will talk to our DRM device and he will do something. So what we see here when we run this like calling Sphero GPU create screen is Mesa is opening up our DRM handle, checking what the name of the device is, and using that to load a driver. And so we have like, as of last stream, we have these changes that basically say like, hey, let's add a Sphero GPU driver descriptor, and let's say that there's like an entry point for this thing, and implement this function. And that's all we had to do, but it took us a really long time to find that. But now we have like a piece of code that we can start implementing that will do something interesting. We don't really know what yet, but we're kind of hoping that if we just kind of follow errors along this thing, we'll see something interesting. So this thing is supposed to return this like pipe screen thing, which I assume is some sort of like implementation for a driver. Because if you look at this thing, you have all sorts of function pointers, like get my name, get my vendor, get this parameter, get the shader parameter, right? Get compute parameter. Like there's a bunch of stuff on here. And so we can probably assume that by implementing this stuff, we will get some sort of OpenGL thing. That's kind of the plan. It's just kind of like, return one of these structures, see where our application falls over, and just follow the errors until we have an OpenGL implementation. And that will probably take many days. So I don't know how far we're going to get today. I don't know how many days it's going to take. But we can just kind of start running around and see what happens. We did try to take a look at just kind of inspecting this code base like without modifying things. But I find that that's quite difficult. There's a lot of stuff in here, and I feel like following errors will tell us what the next important thing is for us to implement in order to understand something. So that's the goal. That's the goal. Let's just start implementing things in this pipe screen and see what happens. Let's see what happens. Okay. So, I guess we should also show what our test app is. So we have like a test app source main. So all of our test app is doing right now is he is initializing he's calling EGL get display, EGL initialize, he's binding an API and trying to basically set up an OpenGL context. He's not doing anything yet. Maybe we could get a little crazy and we could do like a GL clear over here or something. But for now, let's just kind of see what the current state is. I think the current state is that we are not like erroring out in any way. Let's see. Boom, boom. Let's give it a sec. Root test app dev dri card1. Yeah, okay, so we don't see any errors, and then I think that if I remember correctly, we found some pretty sick like debug environment logs that we could turn on. So we did like something like build, right, here is we build our thing, we copy some shared libraries into the virtual machine where we're doing our testing, and then we turn on this Mesa debug, EGL log level, EGL platform. And then I think here we had to say this. I think I forgot to answer this. Isn't Vulkan easier and more sane from a POV of a driver? That's making a big assumption that I know what Vulkan does. And I think that like either way, we're gonna have to get into the Mesa code. And so since I already understand OpenGL, it's like maybe we would maybe we should start with something I understand, even if it doesn't map to the hardware as well. It would be nice if getting OpenGL support was so easy, but I guess you will need a Mesa backend that will convert NIR to internal implementation. Yeah, we'll find out. We'll find out. Who fucking knows? Who knows? Okay, so if I remember correctly, what we saw in here is that he tries to load our driver, I think, and then eventually falls back on software rendering. And I think it's because the thing that we returned here was not like sufficient. If I remember correctly. So where would we be? We were here. We were here. So yeah, I seem to remember. Let's see if we can figure out where this thing is called. We had some logs, but I kind of lost them in migration to like a Git managed repo. But it should be pretty easy to find. I guess it would be nice if we could just hit GDB in this thing. We don't have GDB in our VM right now, but surely it's not that hard to get in. Surely it's not that hard to get in. I think it's worth doing because I think that'll like simplify exploration a lot. So our like virtual machine is using this system build root to generate a user space. And I think that we can just go in here and type like make menu config, if I remember correctly. And this will tell us like, this is like the configuration for our entire user space. And I think, hopefully, if I type GDB in here, GDB legacy config, I kind of want like packages. Here we go. There's package GDB here at 9. So I think if we go in here and we just turn this on. TUI support, sure, fuck it. And then we say, let's back up this config, our build root config. I think if we just type make now, it should build GDB and embed it in our file system root image. I see you love dark mode. I actually don't give a shit at all. I'm not really much of a dark mode lover. I just happen to use it because it was the default, I believe. I think that like with terminals, I typically have them on dark, but I don't really think about it too hard. Oh no, it was looking like I would go to sleep at a fairly normal hour for change, but now your game on. Let's go! Ruin your sleep forever! So what is he doing? He is compiling what looks like I actually can't tell. He's doing some like host compilation, it looks like. which is a little annoying. I hope that there isn't like a ton of stuff to do here. Yeah, so now he's building with the cross-compiling GCC. And what is he making here? I'm worried because it looks like he's compiling a lot of projects. GMP. I was kind of hoping this would be quick. But if it's not quick, then we have a problem. So I'm going to let this go for like a little bit longer. And maybe we just do this in the background while we continue on with our existing workflow. Because if GDB takes this a long time to compile, then I don't want to spend our whole stream staring at it. No libsocket can today, the wait continues. One day maybe. Oh wait, there we go, GDB downloading, so maybe we're almost there. But while we wait, let's get into the the source mesa. And we can try to find where that thing was called from manually. So Sphero GPU create screen. This gets attached to this like driver descriptor, if I remember correctly. And then on here, they have like create screen function, right? So we can look for something that calls like create screen, probably. And we're probably on this path. Yeah. So this was here, and then can we find references to this thing? Create screen. Oh, this is Vulkan. Maybe this is the wrong spot. Create screen. DRM, software, and then STUA device. I don't really think this is the right spot. This looks very like Windowsy, just kind of in my head. It says like WGL at the bottom, and I see some capital letter defines. So I'm not really convinced. Pipe loader software create screen. Yeah, it feels like it has to be through this. So maybe this VK is just like fine. Although this is not. Oh, here we go. Return this. There we go. Here we go. This. Ah, yeah. DRA2 in its screen. So it looks like probably here. And so we can do a little printf here to check. Printf. No screen. Frowny face. And we can do our little same test where we run build.sh and run all this stuff. While we're doing that, we can check he's still compiling GDB, so we will cut him some slack. We're copying some shared objects over to the guest machine. And we do see no screen here, so we have found the right place. And so I guess what we should do here is we should just return a screen. And we will probably, if we just like returned a screen with nothing in it, we would see a seg fault almost immediately. Probably, if we just kind of null it out. And it would be nice, hopefully GDB will come into play. And we will be able to just like backtrace on our failures. But if not, we'll have to get a little clever. So let's just do like, I assume this thing needs to allocate. What do other people do? Right, so can we look at like the VerGL implementation here? Does he like call malloc on this thing, and where does it come from? He like looks like he like caches the screen pointer, sure, but otherwise he calls VerGL create screen, which calls calloc struct, which is in utility memory. So it looks like it's likely that these are macroed for a reason. Maybe in case people want to like redefine these macros to be something else, like if you want to like trace stuff, maybe. Okay, so what like memory thing do they include this? So let's just do the same thing. And it looks like our implementation here of like calling create screen. This is in like a header for all targets, and it looks like the default like thing people do here is they like kind of shell out, or shell out is wrong, but like dispatch to some other implementation file is like kind of what I'm seeing in all of these. So we should probably kind of follow that pattern. So they have like source edit source gallium winsys virgl drm. So here we should make like a Sphero directory probably in source gallium winsys. Sure. So let's do this. And then everybody has a DRM directory as well, so we will do that as well. And I guess in here we will kind of for now just write like, we'll call it Sphero DRM winsys, I guess. Right? Why not? And then presumably, I guess we shouldn't have copied this file. We'll leave it blank. Presumably we need a header file that will like have our implementation. So yeah, this like screen create thing, we'll kind of copy this as well. So this is Sphero DRM public. I don't know why I just tried to fucking hit right in my file system view. That's not really helpful. And it looks like all we have to do here is, I guess we'll replace virgl with a Sphero. And then this is going to be Sphero GPU DRM, Sphero DRM create screen. That seems fine. Seems fine. Okay. So now all we should have to do is in whatever that like target helper, DRM helper, I guess here, where do they include it within their ifdef for their specific driver. We're not ifdefing ourselves out because we don't really care that much about actually implementing correctly. So like we're more interested in how to say this. We're more interested in how this is supposed to work, not necessarily integrating cleanly, if that makes sense. So this is from virgl public. This is in source gallium drivers virgl. This is not what we just saw, right? Were we in the wrong place? We might have been. Yeah, we were in winsys. I don't know how we ended up in winsys. Maybe winsys is, I think I read somewhere that like winsys is the system specific implementation, and stuff under drivers is kind of like could be compiled on any operating system, I think. So I guess we'll kind of follow that pattern. So we fucked up. It was gallium drivers. Aha. Okay, so there's virgl here, and then we'll make der Sphero. And I kind of want to say Sphero GPU. I feel like, I guess GPU is implied, so we'll say Sphero. That's fine. That's fine. And then what was this public in here? As well as, I guess, whatever our like implementation is. So screen. Yeah, we'll call it screen. We'll follow their, you know, their behavior. Okay. Sphero public h and Sphero screen.c. Okay. Nuke everything in here except for U memory. We did want that. And I think we wanted to keep the create screen function, but name it Sphero. But this takes in like a virgl winsys star. So what's going on there? What's going on in there? Okay, let's just leave this for a second. Go back up to the top level. virgl create screen. Let's look at what they actually do in here. So this was in target something. DRM helper. DRM helper. So they call creates. Oh, DRM create screen. No, we were right the first time. I'm just mental. Okay. So we want to call from here, so Sphero DRM, Sphero DRM public, which I think we had somewhere. That's a header that exists. We have to set up the includes correctly, but you know, we'll find it eventually. And then here we should be able to call like return Sphero screen create. And do we need to like pass things in? FD and config, it looks like. It makes sense. Okay. And then we just have to figure out how to get this thing hooked up. So we could look for like vir.gl DRM kind of anywhere. Looks like in their like build file, they have a subdir thing. I don't know what this subdir does. We can look it up. Do I have a Firefox window open? I do not. Mason subdir. Is this like a thing that is defined? So this is like a common thing. Okay. After this, these instruct Mason to go to the specified subdirectory, open up the Mason build files in there, and execute it. Okay. So the idea that they have like WinSys, vir.gl, DRM Mason. And this adds a library. Which means that they have lib vir.gl DRM. And this gets called as link with in Gallium drivers vir.gl. And I assume that this like lib vir.gl DRM, I assume this defines include directories. It does. It does. But okay, so this has like inc gallium, inc include, inc vert.io. I assume this is kind of what we're looking for. Yes. No, not really, right? We're kind of looking for like wherever they had like the vir.gl. Hold on. We're looking for however that include path got resolved. That's our first step here, which is in DRM helper. So they include vir.gl/DRM, right? So what include directory is that? That's vir.gl. So that's in source, Gallium, WinSys, vir.gl DRM here, right? So this WinSys directory must be included by default, right? That's kind of like my gut says. And so we should be able to say Sphero DRM public, which we are doing, but he says it's not resolved. So I wonder if that's like a error in Clang or if that's a true. Okay, so it looks like that he did find Sphero DRM screen create. So we can kind of assume that Clang D is doing something stupid there. He hasn't really resolved our includes correctly. And then now we need to like compile that file. Right? So we need to compile this. So let's look around at the structure of this stuff. So do these guys have like their own Mason builds? They do in here. Okay, so we can kind of do the same thing here. And we're going to say that we are lib Sphero DRM. And we're going to compile our Sphero DRM WinSys. And presumably we don't need vert.io. But we can probably assume everything else is something that we're going to want. Like, and maybe we can like pull stuff out later if we don't need it. Okay. So now the question is where do we like attach that to somewhere else, right? So there's like somewhere they have like lib vir.gl DRM. This gets attached to their drivers vir.gl. And that gets attached to, I assume, lib gallium. Yeah, okay, so we can probably hook in our like libsphero DRM for now. We had no underscore. And then the problem is that file is probably never included. So we're probably going to want to look for like subdir ver gl drm. So wherever they do this, we're just going to do our thing as well. All right, let's see what happens there. Expecting brackets. So we fucked up at dri mason build 62. We forgot a comma here. Tried to use a build target sphero DRM as a dependency of target gallium DRI. You probably need to put a link with instead. Okay. Lib sphero DRI. What was it called? Lib sphero DRM. Let's try that. Okay, okay. So he's recompiling a lot. Also, it looks like our GDB has got in there, so that's pretty cool. Pretty happy with that. This probably rebuilt our whole root FS, so we're probably gonna have to do a little bit of tweaking when we restart our virtual machine for this, but I guess we'll take that as it comes. We give this guy a few more seconds to finish building. He's got a lot of work to do. And I guess while that goes, we can actually go and we can run our virtual machine again with our new rootfs. Subdir, ooh, command failed. Okay, we'll get there in a second. Did we name it wrong? Sphero WinSys. Oh, I guess we didn't actually implement the file, the thing, huh? So let's go here, and this is going to be like this. We need to include some things. So I guess we will kind of copy whatever includes VerGL is using initially. And then we will kind of, you know, just kind of follow what this guy's saying we should undo. This would be sphero DRM public, I guess, for now. And where is pipe screen config defined? This is in pipe p screen. All right. So let's just start here and see if that does anything interesting. So probably in here, do we need to like forward declare pipe screen config like this? Yeah, okay, so he seems happy with that. Okay, let's launch our virtual machine again. We did. And let's get into here and udhcpc so that we can copy stuff over. He's mad because the host key changed because we did in fact reset our root file system, so it makes sense that he's mad about that. He copies his stuff over, and then our test app isn't uploaded, so let's quickly fix that as well. So we compile that, we upload the test app. All right, there we go. All right. What's the fake GPU? We are making one ourselves and embedding it in QEMU, and we are kind of just implementing features on it as we need to. Okay. So it looks like we're chilling here. We have our little no screen comment. And so that means we should be able to start implementing something interesting here. So if we just do something like, what was it? It was like include u memory or something for that calloc macro. VerGL DRM wins this. U memory. Okay, we'll copy this. And can we just do, then what did they do? They did like p screen is equal to this. And they did this. So we'll just kind of copy paste them for a second and we'll see where it goes. So I guess we want like So they have like a VirGL screen coming out of here. And I guess their VirGL screen must have the first element is a pipe screen. Yeah, so we can, instead of doing that right now, we can just create a pipe screen for now, and we'll make our own implementation if we have to in the future. But for now, we'll just kind of start like this, right? And we'll kind of follow the errors as it goes. Which will probably be, okay, so segfault, right? That's fucking annoying. But now we should have GDB available to us, which we do. Sick. So is this a problem though? Do you like GDB test app like this? Run it. All right, wait, okay. Dev DRI card 1. Any segfaults? Nice. We have a backtrace here. Let's go, baby. No debug symbols though, which is a little annoying. Yeah. So how do we get debug symbols in our shared libraries? That's going to be like extremely important. Is it possible that we've configured in release mode? That's very likely. Mason build debug symbols. Like there's probably some thing that we throw onto Mason command line. Build type. Probably what we want. Yeah, this guy's just asking for, so he's giving us a flag that we can use. Okay, so if we go into however the fuck we configured our Mason project, I think that you can just go into the build directory and like change some flags, I think. So let's go to build, our build directory for Mesa, and can we go in like Mason help? Right, we're using Mason that comes from our like build root thing. It's like path is like this, Mason help. Here we go. Configure help. And is there like a, what did this guy say it was? It was build type. Oh, I see debug here as well. Okay, so let's do build type debug. And then if we run Ninja on this again, what happens? Maybe build.sh. Let's just see. So can we look for debug here? Build type debug. Okay. So now we've got a lot of rebuilding to do, but it will be worth it if we can fucking backtrace. That will be a major win for us, for sure. And then we should also be careful that everything that we are using here, we need to copy over. So we have libgbm as well, which we have to reset. Libgbm, Sphero GPU DRI. Okay, sure. Nothing crazy. Nothing crazy. We'll give him a sec to finish compiling. And then we will just need to add a copy of libgbm to our outputs here, which is fine. Really, we could like repackage the rootfs and stuff, but you know, we're taking shortcuts. We take shortcuts around here. And then those shortcuts bite us. We love that. Okay, so we're like build mesa find dot dash iname libgbm dot so star. Okay, so it's like this thing. Okay. So SCP in this like history that we have, we're just gonna tack on a little bit of one of these guys, but he's gonna come from a different directory. This is gonna be like probably something like this. Yeah, copy that chunk of stuff. Put it like this, and then this is going to go to root at localhost user lib64, I think it was. Libgbm. Yeah. Lib64, libgbm so100. Okay. I did put a dot in front of SCP here. And then let's get rid of the GDB because that wasn't working. Okay. GDB test app. Let's see. Run it. Run with dev DRI card 1, our GPU. Heat faults. We backtrace. I don't really see debug symbols still. But also, we do copy this to userlib DRI sphero GPU DRI.so. Userlib DRI sphero GPU DRI. So let's just make sure it's the same. Userlib DRI sphero GPU DRI. Yeah, I think so. We can confirm by doing rm userlib DRI sphero GPU DRI and then rerunning this. Yeah, so that does still work, which means that we are probably chilling. But then why are we not seeing debug symbols? That would have been, let's go what I was kind of banking on here. It could be that the debug symbols are like split. They're not like embedded in the shared objects. That's very possible. Can we look at that and see? Lib mesa was like source find dot dash iname sphero GPU star dot so star find dot dash iname sphero star. Okay. Oh, it's in lib gallium. Right, I forgot. They rename it. Okay, so like if we go to here, and can we like look at like what's this? Yeah, it's not really what I want. Can we like check if there are debug symbols? Linux does share SO have debug symbols? Maybe SO libgbm SO1 is not a symbolic link. That's very possible. That's a good point. But it looks like they are. However, this looks kind of suspect. The date here. Oh yeah, 21:35. So that was 2 minutes ago. So it does look like we're chilling there. Can I like file lib gallium DRI so not stripped? Can we like look at the debug symbols? Can we like list symbol? No debugging symbols found. So that's kind of, I don't like that. I don't like that at all. Because we just rebuilt. So are we building with like, I'm seeing a lot of O2 and -G0 in here, which really indicates that it's not compiling in debug mode, right? That's kind of what that feels like, even though we like rebuilt everything. Right, we went in here, somewhere we saw like build type debug, but clearly this isn't enough. Clearly this is not enough. So maybe we also had to enable like Mason no debug symbols. So this guy's saying, this is what I would have expected. But maybe it doesn't work if we like reconfigure. Enable debug symbols. Can we try this as well? So then do we have to go like source, Mesa, we run our build script again. And that changed nothing, which is a little concerning. That triggered no rebuild. rm compile commands, Mason configure, Mason, is it like Mason setup? How do I like force it to rebuild? Change product options, configure the project. Configure help. Is there like a fucking like regenerate my build files now, please button? Yeah, okay. Yeah, that's not good. Mason setup. Maybe we have to call like. What happens if I just call like Mason setup dot source Mesa dot reconfigure. And then here I probably have to run this reconfigure from the context of like my make file, I guess. So can we do like just slap a like debug here? And what was it? Oh, we have build type release in here. So let's change this to debug as well. Okay, make Mesa. And then I guess we have to rebuild everything. Fuck it. Fuck it. We will full reconfigure. Those build sh reconfigure Mesa. No, it was trying to just run Ninja, not like the Mason part. But usually when you rerun with Ninja, it like, at least like, I mean, I'm not too familiar with the Mason build system, but at least with CMake and what it was claiming just a second ago with Mason is that like generally these like builds configure systems auto rerun themselves when they have to. So I kind of thought that would do it if I just ran Ninja again. And we did see a bunch of files recompile, but unfortunately we did not see a full debug build. So at least our shared objects did not have debug symbols in them, which is a pain in our ass. So let's see if we can get them. Let's see if we can get them. I wonder if we can inspect as it's building. Right, so what was it? It was like source, gallium. Because are any of our shared objects out yet? Drivers, soft pipe. No, we just have to wait for him to finish, I guess, which is fine. We'll live. We'll live. We can wait like 15 seconds. Okay. So what was it? We did GDB on this thing, and we wanted to see, does he have debug symbols? No debugging symbols found again. Which is annoying. Just quite fucking annoying. It's annoying. It's definitely annoying. GDB shared object, no symbol, no debugs. Oh, let's check the compile commands actually. So now we have O0 and -G, which is good. We see that all over the place. And can we look for like a Sphero DRM Winsys? Okay, so he gets compiled with this command. And he is -O0 and -G, which means that we should have stuff generated. And he goes to Sphero DRM Winsys C.O. So maybe we're supposed to like find .name Sphero star, I guess. Okay. Source gallium Winsys. So this probably has debug symbols attached to them. Although I can't open like a static library from GDB directly. There was an O2 G0 in compile commands for Sphero. Was there? Yeah, there's like an O0G here and then an O2G0 down here. Yeah, that's a good point. And probably this one gets priority. So maybe I'm supposed to like, it's possible that like Mesa has some sort of options that I'm supposed to set as well. Which is fucking annoying. O2, look at like -G0 in here anywhere. No. Oh, it's so hard. Build Mesa debug mode. Debug symbols. That's not helpful. Oh, wow. Can we look at like their Mason options? Debug. Oy. Everything's so fucking hard, man. Everything's so hard. Can we go into here? We'll like update our Sphero wins this thing here. I'm just gonna like modify it and then run our build script with verbose mode. And I just want to see what command is printed here, if it matches what's in the compile commands. So in here, we see a GCC command. We do see O0-G. And an O2 G0 is here as well. So that is in fact what's getting printed, which is fucking annoying. Grep O2. No. It's not coming from the environment variables. Where's like a fortify source coming from? Like those must be like some like default GCC options, right? Although then they wouldn't be on the command line. Why? It could be coming from some sort of like Mason defaults for something. Oh, it's so annoying. So annoying, man. Do we keep going down this road? Or do we just try to debug without it? I don't really see how we can like cleanly debug seg faults without fucking like without debug symbols. I want to double check here. Okay, let's just for my own sanity, let's make sure that if I make like a shared object myself, that I can get debug symbols in there, right? Let's make sure that we're not like making assumptions of things that don't exist. So if I do like int some function, and he takes in like int x and returns x plus 1 or something, right? And we say test exe here, and we do like int main void, and we take this some function declaration and we call it, right? Right, so something like that. So if I do like gcc make shared object, I know I can't remember the command line ever. It's like fpic, yeah, and shared. Yep. Yeah. So we do gcc dash fpic dash c test.c. That makes test.o. And then we do gcc dash shared lib test o so from test.o. And then we do gcc dash o test.c l test l dot. Oops, this is o test.c. And it's test.exe.c actually. Okay, so that we need to do ld library path is equal to dot. Okay, so that runs and he returns 5 like we would expect. And then if I run gdb on this thing, we forgot to run all of those compile commands with -g. So we want -g o0 here. Okay, right, okay, and then we want to do the same like -shared and gcc this, and this also wants like -g -o0. Okay. Okay, now he has debug symbols, and if we ld library path is equal to dot, we run gdb, we break on some function, and we hit run. It does think that we're at some function. So that's good. And can we do like info shared library here? And he does think I'm in libtest. So I think we're pretty chilling here. So like, and then if we were just to like run gdb on libtest as well. Yeah, seems like he understands. Right, seems like he understands. So surely a shared object can in fact get debug symbols. So it's not like this is not something that's possible, right? This is something that should happen. And instead, someone in the Mason build is just like fucking us by writing O to G0 somewhere when we think they shouldn't be. I don't really, God. Build systems are so frustrating, man. Okay, so they have like default options here. Default options, debug optimized, and ndebug. Okay, so that's kind of interesting. And then we also probably want to look for like their libgallium DRI shared library definition here. So here they have includes, they have links, dependencies, install. So here they don't like really define any like specific debug options. Hi, what is a fake GPU? It's a GPU from Temu is a funny answer. But no, it's a graphics card that we have implemented in a virtual machine. So we're integrating with QEMU. When somebody calls like a PCI, they like look for a PCI card, and that's one that we have like virtually created, essentially. So it's not real, it's fake, but it does what we expect. I guess, by some metric. Okay, so is there like... So what we already grabbed this for like O2, right? And we didn't really see anything that really matched that. So Mason set O2. Like, where does this come from? This is... They're using O2 for something else here. How to set debug and optimization flags. This is the same fucking thing. Build type to plain. So frustrating, man. Because we set our build type to debug. So it's like, in what world do they think that debug should... Right, we have like build type debug here. So in what world does debug turn into O2? Like, that's stupid. Right? That's obviously stupid. Okay, where is this coming from? Sanity check cross compiler command line. Sanity check compiler command line. Sanity check cross. So this looks like some extra stuff that they're adding to the end, and that's where it's fucking us. Okay. Mason. Okay, can we look at like Sanich? Okay, obviously that's not gonna return anything. Compiler command line adding O2. God, I hate build systems, man. This is just such a waste of fucking time. It's such a waste of time, and it shouldn't be hard for me to be like, turn on debug flags, right? It just shouldn't be fucking difficult. But instead it is. Let me think. Do we check out the fucking, like, Mason source code? I guess we have it already, because buildroot built Mason. So can we, like, fortify source? Okay, so it's not like kind of like, I don't see that like defortify source like stuck in there, or unless it was a fortify source. Yeah, I don't really see this like embedded in the Mason source code anywhere, which is really confusing. Really confusing, because then like where's it coming from? If it's not in Mesa, right? And it's not there. Env grep fortify, and it's not in our fortify. It's not in our environment variables. It's not in the Mason source code. It's not in the Mesa source code. Then where the fuck is it? Right? Right? Like, unless like this feels... Yeah, this is like redefined because it's already passing the command line. So like, what the fuck am I looking at? It must like come from some sort of... Maybe, probably some package config. That's not crazy. That's not crazy. Like, it's reading some config file from somewhere that happens to have it. So we could go into like our build root output. And like in target or host, I think is where this stuff lives, in like this directory. Do they have like package config? They have like CMake stuff in here. Can we like grep fortify source in here? Here. No, yeah, right? This stuff? This looks a lot like it, right? Right? This looks a lot like it. So what the fuck is this? Unless this just defines what it was built with. Yeah, that might be, might be a little bit of a red herring. So maybe like x86 64, x86 64, GCC. Like this is a fucking elf. Okay. So this isn't like some like kind of crazy wrapper script or anything. God, I hate everything, man. I hate everything. So when we like run this build, when we do our like configure, we don't do anything stupid in here, right? Crossfile, this actually looks very likely to be related. Can we open this thing? Build Mesa, build cross compilation. Fucking found it. Fucking found it. All right. Yeah, that's fucking annoying. So where did this come from? So buildroot probably made this thing and fucked us. Probably, huh? But the rest of this stuff is probably important. Right? Like the fact that he tells Mason where to look for libraries and where to like look for package config stuff, like all of this is important. But this stuff isn't. Right? So we need to like maybe look for if we can turn this off in the build root config. Like Okay, okay. Opt. This is in like security hardening options. So is there something that like, do we see like an O2 in here? No. What about like a G0? Debug. Probably in here. Can we look for like where he writes out the cross compilation configuration? Like that's probably also relevant. So can we go to like Mesa? In here, can we like, is there like files in here? Config. What's like this? Yeah, not really that, huh? What was that file called? It was like build. Sorry, I've got like 4 things open right now, so it was in build root Mesa. They had a, where is that configuration? Here we go. Cross compile. Crosscompilation.conf. Okay, so we're gonna look for crosscompilation.conf in source build root. Compilation.conf. Okay, wait, okay. This looks promising. So here they, oh, this is where they get the cross compilation from, but surely somewhere they must output that. Right, like this. So here he has cross compilation conf in. So here the flags are set by target C flags and target CXX flags, right? This is where we were seeing those like O0, OG, or O2, G0 stuff. Target C flags must be like defined somewhere. Package makefile. Okay. Host C flags, target optimization. Aha. We found it, boys. We found it. So we need to turn on enable debug. Probably, we want to turn on enable debug and optimize 0. It kind of sucks that you can't override this for a particular project. And I guess we actually don't want this to be done on all things in our sysroot. Probably what we want is we just want to we want to use our own cross compilation definition. That's an easier fix here. So I think what we do for now, we just hack it. Probably. That's kind of where I feel like this should go. So let's go in here and we'll take this cross compilation conf and we'll kind of put this somewhere. We'll just kind of stick it here for now. And we'll just kind of delete these. The rest can stay on. The rest can stay on. And can we, oopsies. Can we edit this now to use the cross file at just the one that we just made here, crosscompilation.conf. Okay? And now, hopefully, we wipe out our build directory one more time and run make mesa here. And hopefully now we will see that O0 fucking disappear. Let's turn off fortify source as well, huh? If he's bitching. You know what? You know, if you guys don't want it, we don't need to give it to you. You know what? If you're gonna bitch and moan, then fine. Fine. Looks like it worked. Yeah, that's true. The fact that it was bitching and moaning does kind of seem like it worked, huh? All right, dude. That's a real cool use of an hour, man. Really cool. Really cool. Love that. But I mean, I guess like I don't know what it is. When I'm bug hunting in code, I do not like have a problem with it. But there's something just like so soul crushing about working with build systems. I don't know what it is. I just hate it. I hate it so much. And I think it's because like in my mind, building the code isn't part of the code. Right? So it feels like this like extra piece of work that I have to do the thing that I want. Where usually when I'm like debugging code itself, it's like, yeah, well, I mean, this is what I signed up for. But fuck, I hate it. Like, I wish I could reframe it in my brain so that I didn't hate it, but I really doubt that I'll be able to do that. Okay, so let's get into the Mesa thing, and let's find our thing. And can we, it was like lib gallium, I think. And we run GDB on this. And he has debug symbols. Let's fucking go, baby. Let's fucking go. Okay, so let's do our like build and upload all this stuff to the virtual machine, except we accidentally closed the virtual machine by mistake. We accidentally closed it by mistake. And you have to know a little of all of them if you're doing anything significant. It's a big piece of work. Yeah. Yeah, I think that's it. Like, it feels like, yeah, I don't know. And I feel like they're all shit. That probably doesn't help, right? Like, the fact that they're written in these, like, shitty scripting languages makes it so that, like, reading through them, you don't get all of your, like, normal tooling. If not for build root and the fact that you're cross-compiling, it's much less painful on host. That's true. That's true. It's definitely not helping. Definitely not helping. But I want to work in the virtual machine. Failed to upload file. Whoa. Why? Fuck! Fuck! I'm out of space on the VM now because my fucking file system root size was too small. This is fixable as well. This is easy to fix. This is easy to fix. This comes from our build root config. FS root FS. There's like something about like my like file system size, I think, in here. Oi, 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 oi. I just don't remember where. I think that we've changed this in a previous build root. Initial commit, simple overlay. Okay, none of that did it. I'm sure that we've hit this before where like the file system size wasn't big enough. Yeah, here we go. ext2 size. ext2 size. Okay, let's just fucking crank this motherfucker. 512, baby. 512, baby. Make. Please, God. Builds doesn't feel like shit because they're all opinionated. Other programs got fed up with the same nuances and rolled their own to fit their own mental model. On that note, I'd like to introduce my build since it works perfectly on my machine. Perfect. Is build root just using cross-compile tooling to inject flags, or is the VM in effect another arch in the host? It's in the same arch, but I just wanted something that like I wanted all of the software like compiled because I didn't know how to do it. Build is kind of overkill. You could have been using the same kernel from the same host and QEMU, but that I need a rootfs, right? I need a file system that stuff lives on, and so build root seemed like the easiest way to get that for me. It seemed like, because I didn't want to like compile all of Mesa's dependencies and put them into the virtual machine myself. Charbit, thanks for the prime, much appreciated. So, I don't know. It's like maybe a little overkill, but not the end of the world. Not the end of the world. Alright, run. So now we are going to have lost all of our modifications to the root fs again because we recompiled it, but that's okay. That was intentional. And if we df-h dot, let's go, 389 megs available. Let's fucking go. Okay. So we need to go into test app and we need to upload our little test app. We need to turn on networking. Is that you, like Zig, have its own build system? I do like Zig. I don't really know what you're asking. But maybe. All right. Let's get back into Mesa, our Mesa mods. And maybe now we'll be able to upload our thing and run it. And please, God, please let it be over. GDB test app. GDB args test app. Dev DRI card 1. Run. Okay. Let's go! Those are some fucking source files, baby. Let's go. Okay. So we're at DRI2.c line 2393. Okay? DRI2.c line 2393. Fuck. Wrong DRI2. Front end's DRI2.c 2393. Let's go! It crashed one line after it crashed, like pretty much exactly where we thought it would crash. Really, if we had done none of this work, we would have found this immediately. But now it points us to it. So, you know, that's a win for us. That's a win for us for sure. Okay, get param. Get param. What's this supposed to do? Who knows? Who knows? LG, thank you for the tier 1. Much appreciated. Much appreciated. Okay, so what the fuck is this? Queried integer valued capability parameter limit. All right. So I guess we are going to look for usage of this thing. So in uScreen, whatever the fuck that is, he returns 1 for this. Is this an implementation of this thing? Get param defaults? Probably not. Can we look at like the OpenGL implementation of this thing? Right, so like what does this guy do? So we're looking for cap throttle. So he doesn't have a specific override for throttle. But what happens if we get to the bottom of this thing? So here he just like uses the defaults if he falls through, if he makes it down here. So we should just implement our function as use the defaults, and then we don't have to think about it. So can we go to our implementation of where the fuck this is? It was here. And I guess what we will do is we'll say screen get param is equal to this, essentially. Right, which means that we need to find this definition, which is in uScreen. Auxiliary util uScreen.h. So where do... It looks like we don't have to set the auxiliary thing. Oh no, we're in the wrong spot here. So here, do they have util uScreen? It looks like is what we want. We'll just slap this here, right? And then run our build again. And surely he's going to crash still, but now maybe in a very slightly different spot. Yeah, okay. So let's do the same thing. Quit, run. Okay, so now we are in pipe screen get param defaults is seg faulting on something. So let's take a look at this. So it's uScreen.c444. So he is trying to call get screen FD. And he says, hey, do I support pipe cap DMA buff? I do if... Well, I don't know if these ones are zeros. If like is 1 I support it. It's hard because often you have 0 as success in C so that you can do if failure. But I'm pretty sure that here 1 means I have it. But we could... Right, because this says if our file descriptor is -1, then we return 0, which means that like this is not something that we can do. So my guess here is that we can just do like get screen, like was it get FD something, get screen FD. So we can probably just implement this and just return -1, would be my guess. SPHAERO, and we can just return -1. Now, I assume that, at some point we're going to want this, right? Like maybe this is like a feature that we want, but for now we can just kind of get away with cheating. We're not really trying to do good here. We're just trying to not crash. And then eventually we'll have features that we want to implement. But for now, we don't do it this way. They want me to say like pipe screen here, and then they want me to do like void screen or something probably. I don't know if they warn on unused. They don't warn on unused parameters, which is huge for me. Huge for me. Okay, driver must implement these failed at uScreen78. Love that. Love that. Okay. So can we look at like what they do in VerGL? So these are our max texture size. Maximum, okay. I think that I understand what I'm looking at here. So this is saying like, do we support swizzling? Which is not what we have to support. We just need 2D, 3D, and cube levels. So I don't know how 13 is 4,000 times 4,000. Or how 9 is 256 by 256 by 256. But I do understand this. Max texture size at 16384 does make sense to me. So it looks like we kind of need to implement this like Sphero DRM screen get param. Sphero DRM. It's just get param here. And so here we will implement the same API here. Right? And then like they did in the other thing, like they did in the other version, we will kind of fall back on this defaults in some case, right? So we're gonna like switch on param, and we'll say default, we do this, right? But then we have to implement whichever things that he was mad at, so presumably, I don't know. Who calls getParam, first of all? I want to know like what the error condition of this function is supposed to be. If this, then that. So I guess we return 0 by default. Oopsies, that's the wrong place. We return 0 by default to kind of indicate that we don't support that thing. Or maybe we assert false here as well. I guess if we have a default case, we literally can't get here. So we don't have to do that. DRM, Sphero DRM, get param. Okay. So then all we have to think about is the things that it said we have to implement, which were these. So that seems reasonable to me. Here we have to figure out what the fuck these are. So who calls this? Max texture levels. Number of texture bitmap levels. Oh, so I guess each one is a power of 2 for 2D textures. But then for other ones, for like 3D textures, it would be 8. And I don't know what a cube level is. Okay, so this makes sense to me, I think. Let me think for a second. So if each level... No, I don't understand. Right, I'm thinking like in terms of like bitmap levels, where you would like have like a low res thing, and then you kind of like split it up. This is like what I imagine bitmaps are. I don't actually know, right? So you have like basically higher and higher detail the more into this you go. Then I'm imagining that like in 3D, you would kind of like do like something similar where you kind of like block off like a cube in the corner and then you do that again on the way down or something. So you're saying log base 2 of 4096 plus 1 is equal to 13 is how he's getting this. So why? That's like how many splits you can do, I guess. Sure. I mean, I don't really want to think too hard about this. Let's just do like 5 and 5 or something. And we'll just write like a arbitrary. Then I don't have to think about it. We'll just go lower than what they did. Okay, now he's mad at 78. Oh, because we didn't actually use the function that we just wrote. It's a really good point. Really good point, computer. Okay, now we're just at like another seg fault. So let's go run GDB again. Which I guess means we do this again. Five means 16 levels. Winky face. I don't want to think about it. I don't understand. BT. There we go. So this is in get version st init limits at stextensions.c. State tracker state extensions. Okay. Okay, so this is kind of interesting. So we're seeing, let's like actually think about this a little bit as well. So he's calling like, give me a screen, and he's asking for the version of something. And in here, he's initializing limits for that thing. So let's go to stextensions.c131. And he is calling getParamF. Okay, so this is just the same shit, right? Where getParamF is just getting floating point things. So we can assume that they have another similar, like, oh, they don't have a default here. I thought they would. I thought they would. Surprising. Surprising, for sure. Yeah, I would have assumed. Okay. So I guess that means that we have to actually like understand what these things are. And I guess we can do the same thing that they did, and they just like log and return 0. Seems pretty reasonable to me. Seems reasonable for now, right? We don't understand what anything is, so we just do the stupidest thing we can, and then come back to it later. Right, so return 0.0f, and say, unknown param, unhandled param, like this. Did they have like a nice little name? No, they just wrote the number. Pipe cap param this. All right. Fuck it. You know, fuck it. All right. We go again. We go again. I think 5 means 5 levels, but yeah, that translates to a texture size 16 by 16 pixels. I see. I think. Because 2 to the 4 or 2 to the 5 is 2, 4, 8, 16, 32, but then minus 1 or something because the first level is level 1, not level 0. Something like that. I'm not sure. I'm not going to pretend I get it. ST extension is 131. Oh, because I didn't assign it again? Get paramf is pharaoh DRM get paramf, which kind of means that here we've been naming other things. We named this one Sphero DRM get params. We might as well name this thing Sphero DRM get paramf, I guess. I don't know, man. There's an error not supported. That's why it's plus minus 1. Got it. Got it. I think I understand. He says, probably not understanding. I mean, it does make sense though. You're splitting 1 power of 2 for each level. Makes sense. Okay, so now he's mad at a seg fault at uscreen 525. So he's asking for get shader param with this stuff. So can we just error out on this case as well? Okay, so we have a VerGL implementation that we can reference. I see. So he has shader and parameters for each shader. So let's just return 0. For now. Win Sphero Winces. Here we go. All right. So here we say get shader param. Boom, boom, boom. And then here we just say printf got shader request for shader this param that. Okay. And then we return 0. Very scientific, very scientific. I wonder how many of these things there are. Oh, okay. We got farther. We got some spam logs for sure. Pretty cool. Okay, now he needs these. So this was on pipe cap. So we just kind of like slap these in here. And we look at VerGL, and he's got -1 and 0. Let's just fucking run it. Okay, new seg fault. New seg fault dropped. New seg fault just dropped. But again, we hit run, we hit backtrace, and we go again. I view the +1 more that the number of levels is log to range between 1 to size inclusive, like the linear range between e.g. 3 and 7 inclusive is 7 minus 3 plus 1. Gotcha. That makes sense. stextensions.c line 679. Okay, so now he's asking if a format is supported. Check if the given pipe format is supported as a texture or drawing surface. So here we're just gonna like fucking like hard return false, right? Surely we support nothing right now, right? Okay. So this is Sphero DRM is SPHAERO. Okay, and then we just kind of like return false. And really we should log, right? Rejecting format. I don't know. I don't really feel like we need to write all the arguments down. We just need to like at least notice that this is happening. Damn, not sure anymore if someday I end up implementing Mesa stuff for my GPU. Well, maybe we'll find out that it's simple, right? Maybe after we get through all this, we'll be like, oh, this actually was fine. But maybe not. Maybe not. Maybe we're going to do this for like 3 days and be like, holy shit, we still haven't found all of the APIs we need to implement. In which case, maybe we would give up. Okay, wait, okay. So now we're on DRI release screen. This is probably trying to find the file descriptor or something. No such file or directory. Sure, but this is a DRI screen 810. Yeah, so he's trying to destroy the thing. Which I assume is just like a close of the file descriptor or something. I guess he doesn't really do jack shit. I mean, he's doing obviously he's doing something that for him, but I guess this is like free up any resources that we allocated on construction. And since we are not creating like a wrapper around the thing that they're giving us, then we don't really have any stuff to clean up. So we can kind of just like null this shit out, I think. I mean, let's just be clear, we're making a lot of like educated guesses, right? Because we kind of figure if we're wrong, the consequence will just be it doesn't work right. And it already doesn't work right. So really, we can't get any worse. Sphero DRM destroy. There we go. And here we'll just do nothing. Screen destroy is Sphero DRM destroy. Boom, boom. And what's he pissed about? He doesn't get like it if I don't write static here because he's like, wow, there's no matching function in the header. You have such a cleanup, you allocate a screen, so you might need to at least read. That's a really good point. It's a pretty good point. I did allocate a screen, didn't I? I forgot. It looks like we want to call free. We want to yell free at it. We really want to make sure that he hears us. You know? You know? Okay. So, but it looks like we made it to something without crashing. Now, likely, we are falling back on software rendering here. We see that we do like... Hold on. There's a lot of spam here. Holy fuck me. How do we find quit test app dev DRI card 1 and we pipe everything into standard output and type less. Oh, and then we need to run with our like fucking debug flags, right? So it's this stuff, which I can't paste. That's cool. Love that. Love that. Maybe I should have just SSH'd in. That would have been easier. But it's fine. So can we look for like Mesa loader? Well, he only ever actually loads SWRest. Fuck. Okay, sure. But I mean, I'm pretty sure we'll be able to find somewhere that he gives up. That's probably why he's calling destroy, right? So probably if we do like GDB on this thing, and we probably break at Sphero DRM winsys.c line 48. And then we hit run here. Hopefully this will set the breakpoint once Mesa loads, like calls DL open our library. He does, and we can look at where this is coming from. Right, so this is coming from DRI screen create for driver, create new screen. And so probably here, he's hitting some exit condition that he doesn't like. So DRI util, and it was 141, I think. Yeah, so here he's like, hey, I want to initialize this screen, but I got no fucking driver configs. So like, fuck this shit. Let's get the fuck out of here. Right? So that means that our init screen call is probably coming through here, DRI2 init screen, and then probably somewhere in here we're just like giving the fuck up. So I would imagine it's here. So this is 2401. We just run this again and just see. Let's just see. Okay, p configs. Yeah, so this is null. That you guys can't see this probably because it's like fucking dark ass blue on dark ass black, but it looks like this init screen is returning configs, and that configs is null. So why is that? Where does this end up in our driver? I guess maybe we breakpoint in DRI init screen and just kind of walk it and see what happens. I guess it would just be here, DRI fill in modes, right? It would have to be, because this is the thing that's returned. Nothing else really matters. So in here, we have configs that goes for each format. So probably he's checking if this is probably us rejecting every single possible format, right? That would be my guess. Right, we saw a bunch of like log spam of like rejecting format, and this looks a lot like he's iterating formats to check if they're supported, right? If it's not supported, he continues. So we have to support at least one format. At least one. Which, I don't know. RGB, probably RGBA. Like Mesa format. Can we just do this? What is unorm? Float, sint, uint, unorm. Like, what the fuck does this mean? Mesa format none seems easy. surely that one's not. That's like a sentinel value, right? Surely. Yeah, they're iterating this thing. I mean, I guess we just take RGBA unorm. I don't really feel like I understand what unorm means. We can ask maybe like Mesa unorm format. What does it mean? Unorm. N-bit integer normalized from 0 to 1. Oh, okay. So I kind of want like, don't I want, I guess if our options are unorm and sRGB, what is like sRGB here? sRGB color space. So that's probably what we want, right? sRGB is 0 to 255, right? I actually don't know. Oh, this is also normalized. It looks like according to this graph, whatever the fuck that means. I've looked at this page so many times, and I feel like I will never really understand what it is. I'll have to come back at this for like a 50th time another time. Fine, fuck it. I guess we'll use RGBA unorm. I don't really understand how it's 8 bits if it's normalized. I guess the 0 to 1 is actually 0 to 255 would be my guess here. But I guess we'll find out in the future whenever this comes back to bite us. Because if we say we support it, you know. So we'll say if. How does he call this? He calls this with format as the second argument. So format is equal to this. Which comes from, you know, somewhere. This is in formats.h. VirGL DRM wins this. Is format. What is it called? Fucking. Is format supported? Yeah. So what do? They do a lot of stuff. A lot of stuff. I guess we have to check like the sample count and stuff too, huh? What like headers do they include here? Like format, format probably sounds like what we want. Probably. No. Hold on. Oh, they're using pipe format. They're using pipe format. Okay. Okay. Let's go back for a second. So what is the equivalent pipe format? We are supposed to be in like DRI screen. So if we want RGBA 8, this is do we say RGBA? We did, right? So this is just this. Okay. Okay, so that's step 1 out of the way. We have like a define that is resolved. And now the question is what did the fuck did the VirGL screen people do? Oh no, I actually wanted to know what we are called with. That's what actually I want to know. So they call 0, 0. I see. So first they check if it's supported with 0 samples. Then they check for a given number of samples. So let's just say that samples has to be less than 1 or something for now, so that we don't have to deal with multi-sampling, and see where that gets us. So this is storage sample count and sample count. So we'll say if format is this and sample count is less than 2 and storage sample count is less than 2. Return true. Okay, yeah, let's see what that gets us. Let's see where that gets us. sRGB is nonlinear. It looks better for eyes. Most screens expect sRGB, but UNorm is fine too. It looks a bit unsaturated. Yeah, I mean, I've definitely looked at all this stuff before, right? Like, it's also something like sRGB is approximately like a gamma 2.2 curve or something, but then like it's not really exactly. And then there's something about like inverse gamma encoding because like monitors used to do like gamma encode stuff, and so you have to like store the inverse for some fucking reason, and that's also related to sRGB in some way, shape, or form. I don't fucking remember. Yeah, but I do understand that it's like non-linear and better for our eyeballs, and maybe only because of like the way computers store stuff, but also maybe not. Is this a game? You could view programming as a game for sure, for sure. But we are more trying to explore how graphics cards work in the attempt of, in the interest of one day writing our own graphics, writing is strong. It's like not really the right word, building our own graphics card. But I figure it's good to tackle this from the software side first so that we know what we're trying to build to make the software that exists happy. So we are making an OpenGL driver for a fake GPU, integrating with Mesa, trying to figure out what the fuck does Mesa want out of a GPU in order to, do the things that it's got to do. You know? All right. So where were we? We were in like DRI2, DRI screen. Where were we that ends up calling destroy? DRI create configs failed. This is what we're looking for here. So this is the same fucking function. This is the same function. And so where does this come from? Num MSAA modes is equal to, he calls DRI could create configs, concat configs. So this comes from, oh, this is confusing. Okay, so these DRI prefix functions are not using, oh, this is not DRM, this is DRI, which are different. Great. Jesus Christ, what am I looking at? Creates a list of glconfig that a driver will expose. A set of struct glconfig will be created based off the supplied parameters. The number of modes processed will be 2 times num depth stencil bits times db modes. Okay. For the most part, this data is just copied from depth bits, stencil bits, db modes, and viz type into each struct glconfig element. However, the meanings of frame buffer format and frame buffer type require further explanation. Can I just not think about this? Like, can we just like fucking breakpoint here? Break on DRI screen C line 555. Yes. Run it. Run it. Let's just see if we like, let's just see where we're trying to fucking. No, he doesn't like that. Really? Why? B DRI screen.c line 555. He doesn't like that. Info shared library. Oh, because I forgot to run with dev DRI card 1 probably. Which is important. We need to use our GPU to see our GPU. You know? I actually still didn't breakpoint there. That's kind of surprising. Can we breakpoint on... Maybe we're getting too quick. Maybe we need to breakpoint here. Maybe. Okay, so here we go. We're getting somewhere. Okay, so there's a continue here. Maybe we should print out in Sphero DRM Winsis here. We should print sample count, format, sample count, and storage sample count. We must be rejecting this. And then can we write these things down? So format, sample count, storage sample count, and then here we can be like printf success, or it's supported. It is? It's, yeah, apostrophe S. And it's rejected. That is literally the first time I've ever heard you say your own name. Okay, now I get it. I mean, yeah, I guess I don't really you don't really go around saying your name that often, right? Like we're not like Pokemon where we just go around Sphero. So I guess that makes sense. Okay, what sample format are we expecting to see here? We're looking for. Oh, come on, man. I don't have numbers anywhere. I have to like fucking check. We'll say expected format. I guess we'll say like if format is not equal to this, return false. And that way we can like filter out. We should only see logs if we are fed in the format that we actually care about. And then we can kind of see why it's not working. That's probably the way. Probably the way. Okay. So we do see some supported formats, right? So that's good. And then we see one here as well as one here. And then he's then asking for shader parameters again. But maybe that's, yeah, that's here. So got shader request. Okay, so it looks like, like at least at some points in this loop, we do get through. So I don't really understand why this is returning null here. Got shader request. So it must be that like somewhere down in these like DRI create configs or concat configs. Concat configs is doing nothing. Is create configs calling into our driver somewhere? He must be. He must be. However, I do not really see, this looks a lot like he's just kind of doing like, you know, some data management. Like he's not really going crazy. Right? Like this is not taking in our driver anywhere. In fact, in here, is our driver being passed in anywhere? No. No, he's not. So how is this failing? I don't understand. Because surely by the end of this loop, we should have at least one config. I guess if num mesa modes doesn't get set here. Oh. Nope, don't understand. Because here we see, I'm pretty sure we see that like we get at least some success here because our samples are getting passed in as non-zero. So they're seeing sample count 1, storage sample count 1. And we're saying it's supported, right? So num mesa modes should get incremented here, right? So we should expect num mesa modes is this number. We expect this, oh, num MSAA modes, my bad. Not mesa. Mesa. Very slight difference. We expect this to be non-zero. Hello? Maybe we're not making it here. Like if we're like continuing early. Or maybe I'm not like uploading the right library. Maybe we're recompiling something. Maybe we haven't recompiled all the drivers that we have to. Oh no, here we're seeing, okay, wait, this makes sense. So we get it supported, then we come down to num MSAA modes here. Okay, so we're seeing logs for these. Is format supported, I guess, in some cases? I'm quite confused. It would be nice. Maybe we just breakpoint. Okay, so the breakpoints don't really help me though, because they're so slow. I want to see like why we're continuing, I guess, in the cases where I expect that we shouldn't. So here we'll say format supported like expected. Okay. Yeah, okay. Hold on. So I'm actually quite confused here now. Because I really thought this loop was what we were seeing with is format supported. I really thought it was. Because we see it like walking down in our logs, right? We see this coming down from like 16, 15, 14, 13, 12, 11, 10. Am I just in the wrong fucking function? No, because I'm seeing this. Right? We're seeing num MSAA modes get printed. Here. Then we're never seeing this happen. Right? Loop goes up though, so it cannot be that loop. That's a really good point, huh? That's a really good point. That's a pretty goddamn good point. Which then lines up with this never returning. I wonder if we can do something like render target, display target. So here we do return true sometimes. But never after that num mesa modes log. Well, it's really hard to tell. There's like a million fucking. Can we reject logs unless, can we like, if format is not, can we just like remove all mesa formats from this list until we see the one that we expect? That way we can reduce this log spam, right? Okay. So right before his little complaint here, drm create configs. Am I just looking at the wrong function? Did we just fix this and I didn't notice? Dri create configs, okay. No, this is definitely the right spot. Definitely the right spot. This looks relevant here, right? Allow RGBA ordering. Looks like we want this. Aha, aha. Aha, okay. What's happening here? What's going on here? DRI loader extension. Image loader. Okay, hold on. So, well, I guess we just won't use RGBA, and instead we will use BGRA instead, because I don't want to figure that out right now. Aha, BGRA. And then in our thing, wait. Yeah, does that make sense? Yeah, I think that makes sense given what we're seeing here. Okay, so let's try this. BGR here and here. Let's try that. What if I always return true on supported format? I don't want to do that. I don't want to do that. Okay. That looks interesting. For sure. So it looks like we successfully opened our little thing, right? He says now that we like got Sphero GPU DRI open. And we have like some like debug logs here, but it doesn't look like our test app is failing anymore, which is pretty cool. Pretty cool. I wonder if we can like try to do something like execute a GL clear or something in our test app and just see what fucking happens. I'm curious. So if we go into here and we just call like GL viewport, probably need like gl.h or something. Is this where this comes from? gl.h like this. Yeah. Like if we do like something like this and then cgl clear, color is like, you know, red. And then we do like a cgl clear with a cgl color buffer bit. Like, I wonder what happens here. We do need to link against libgl now. That is true. I will give them that. Okay. I mean, it looks like that's doing something. Stood debug print. Hi, mom, we are finished. Smile. Like, does that work? Wait. No? Oh yeah, hi mom, we're finished. And then there's just some like printf buffers that ran out. So it looks like we're chilling. Now that function is a no-op stuff. Seems pretty important, right? Right, this stuff? Before, aren't you calling that stuff too early before creating context? That's a really good point. I thought that we had already gone through all that. I actually thought we were down here. I was just confused. I was confused. Thank you. You are correct. This makes way more sense. Way more sense. Little seg faulty. Let's go. Thank you. I was getting ahead of myself. So what's going on now? So this is on context creation. Of course this will fail. Of course. So can we look at what that does? Should we look at what that does now? It's 4 o'clock. I feel like we just got through a little bit of a win there. And I think that if we try to pick up something else, we're going to like lose our minds. So I think we're going to leave it here and we'll say that EGL initialization and display creation seems to work okay. Work okay by some metric okay. It doesn't crash. If we call bind API, let's kind of like at least try to see how far we've made it. So that's fine. I guess here we'll say we'll move this log to be right before the return so that we'll make sure that we see it. What's annoying, yeah, here, we see it here. Let's see if choosing configs, I think we saw create context is where it failed, right? So we should see it this way. Let's turn off these annoying environment variables now that we don't need them for right this second. Hi mom, we're finished. And then I expect that here is where we will see the crash on context creation. Yep, okay. So I think that we got, you know, pretty far here. We got through get display, initialize, bind, choose config, create context. No, we didn't go through create context. We got up to create context. So I think that is, you know, a fair amount of stuff to get done today. I think that if we were going to keep going, it would be likely that we would spend way, way, way too long on this day. To the point where people get bored. So we'll come back tomorrow. We will come back tomorrow and we will try to get to the point where we can do this stuff. Yeah, so thanks for watching, guys. If you like what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. It is 4 o'clock Pacific time now, so you should check in between 3.5 hours ago and now. For today and tomorrow, we are not doing the 12:30 to 2 segment, which is we call happy hour, where we kind of do like less focused new work and more like cleanup, unit testing, vibing, you know, shooting the shit, whatever. So if you guys want to check that out, those will not be available today or tomorrow, but they will be back on schedule on Monday. If you're watching on YouTube, you will not see the happy hour content ever posted. You will see that under the members only or Patreon section stream. So if you want to check those out, you can get behind the paywall. What else do we usually say? Like and subscribe because we're fucking YouTubers, and use your Twitch Primes if you have them. If you want. What else? GitHub link in the Twitch description if you want to see the code for this stuff. It will eventually end up under GPU testing environment. I cleaned up a little bit of this morning, but there's a little bit more to do for the stuff that we're seeing today. Yeah, otherwise, I will catch you guys later. Goodbye, YouTube, and Twitch. Let's find someone to raid.